Hello, Honors Algebra 2. Today we will be talking about linear inequalities in two variables, and this is something you may have done before, and it should not be too challenging. We're just going to go ahead and go through problem number 4, which is right here, and then we'll do the cricket problem in class tomorrow as review. Okay, so here we go. You may want some highlighters if you want to make your graphs extra pretty, but it is not necessary. So what we're going to do is graph the inequality, and we're going to shade true. So this first one, I'm going to graph the inequality using the intercepts method. So my x-intercept would be when y is 0. And for now, I'm just going to go ahead and use an equal sign to find my intercepts. So I should get 2, which is 2, 0. My y-intercept, x would be 0. So when I solve, I should get 4 or 0, 4. You could also choose to solve this for y and put it into slope-intercept form if you would prefer. I'm going to do that for the next problem over here. Alright, so now once you have your intercepts graphed, you're going to have to look ahead at your inequality symbol. And because we have a greater than or equal to sign, this equal to part makes the line solid. So when you draw your line, just draw it like you normally would. But now since it's a greater than symbol, that means we're going to need to shade a particular direction. Some people just say, hey, greater than means above, and so from your y-intercept you're going up, and we would be shading this part. However, a lot of times we prefer to just use a test point. 0, 0 is the most common test point, so what we'll do is we'll plug 0, 0 into the inequality, and we'll see if we get a true or false statement. So this becomes 0 plus 0 is still 0. Is 0 greater than 8? Well, no, it's not. So that means that where 0, 0 is, and this whole side of the inequality over here is false. So we are shading the part that is true, which is everywhere where 0, 0 is not. Alright, let's try the next one. This one I'm going to go ahead and solve for y. Although again, you could do intercepts if you prefer. Be careful because when you divide by this negative here, it is going to flip your symbol. And now I'll go ahead and graph this. Intercept down at -3 and up 3 over 1. Again, I don't care which method you use to graph, as long as I have some sort of work knowing how you did this. Alright, now notice you have a less than symbol here. There is no line underneath it. That means that our line is going to be dotted. And now I'll use my test point again. I'm going to use 0, 0. Because 0, 0 is easily distinguishable as on this side over here. So I'll plug 0 in, and I get 0 minus 0 is 0. Is 0 less than 3? Yes, it is. So that means that this side of my graph is my true side. So I'm going to graph everything over here. Alright, there we go. Moving on. You have $200 to spend on CDs and music videos. CDs cost $10 each and music videos cost $15. Part A, we are going to write a linear inequality to represent the number of CDs, X. Okay, so CDs is our X. And music videos, Y, you can buy. Alright, so think about this. If you have $200 to spend, that means you can spend $200, or technically you could spend less than $200. So you need to have a less than or equal to sign. And then the rest of this is just like something that you have seen before. So we have got, I'll close my email here. We have got CDs are X and they are $10 each. And music videos are Y and they are $15 each. And there's your inequality. So let's go ahead and graph this and then we'll find those possible solutions. First, on your x-axis, I'm going to put number of CDs. And my y-axis is number of videos. And this is fun shopping spree. Yay. Oops. There we go. All right. So I think we're just going to count by ones here. Let me find my intercepts first, though, so I actually know what I'm looking for. So let's see. I guess we'll show our work down here. X-intercept is where y is 0. So you should have an x-intercept at 20, 0. And your y-intercept is where x is 0. So we're going to have 15y equals 200. And this is going to be, I think, 13 1/3. You can check that for me. All right, so I'm just going to go ahead and I'm going to count by ones here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I hope that's 20. And 13 1/3. And a little more than that. Oops. Okay. And this is less than or equal to, so it will be a solid line. And let's try that again. There we go. All right, now, technically speaking, because this is a real life situation, even though our line would extend, we can't actually use the part that goes into the negatives because we can't buy negative videos or negative CDs. So you could get rid of this line extending or make it dotted. Okay, now, ordinarily we would shade, and when we plug in a test point of 0, 0, you should get 10 times 0 plus 15 times 0 is less than or equal to 100 or 200. That is true, so we would generally shade here. Here's the problem with that. If you shade this whole section, that means that you're including decimals as well, and you can't actually buy 13 1/3 videos or 13 1/3 CDs, or 2 1/2 for that matter. So the only things you can really buy are these whole number items. So instead of shading, we're going to put dots at all of the whole numbers. Now, I am certainly not going to make you put a dot for every single one of these, but it really should have one. Okay, a dot for every whole number of items. So technically speaking, this 13 1/3 is not realistic. We don't have enough money to buy 14, but we could buy 13. And this is an example of where a real life situation limits what our equation can actually tell us. Okay, so you'd have dots all over here, yada, yada, yada. And now we're just going to list 3 possible solutions. So you could buy 20 CDs and 0 videos. That would be this point over here. You could not buy 13 1/3 videos and 0 CDs, but you could buy 0 CDs and 13 videos. Or you could really buy any of these dots. So this one right here would be 1 CD and 1 video, that 1, 1. Those are just some examples. And finally, we've touched on this briefly, but why is this only in the first quadrant? Well, we can't have negative CDs or videos. So most of our real life situations are going to take place in just the first quadrant. All right, one more. Flip to the back. You have $15 for fresh fruit for a party. Write a linear inequality in two variables for how many pounds of strawberries, X, at $1.25 per pound, and cherries, Y, at $2.40 per pound you can buy. What are the intercepts of the graph and what do they represent? All right, so this inequality is going to be very similar to the one we just did. You only have $15, so that's going to be less than or equal to 15 because you can't spend above $15. And we have $1.25 for the number of strawberries, and we have a $2.40 for the number of cherries. So this would just be your inequality. Now for your x-intercept, you're going to find that like you normally would. Y would be 0. And don't worry about using an inequality here because you're actually finding an intercept. Okay, if you do 15 divided by 1.25, that should give you a 12. So make sure you actually put your x-intercept is 12, 0. Y-intercept, that's where x is 0. And when you divide, you should get 6.25. I'll let you type that in. Again, make sure you write it as an intercept. But then what a lot of people struggle with is what this actually means. Like, great, this is an intercept. What is it talking about within your real life situation? So you have to come back to what we did over here. 12 for x is talking about the number of strawberries. 0 for y is talking about the number of cherries. So what this really means is with $15 to spend, you can buy at most 12 pounds of strawberries when you don't buy any cherries. And likewise for your y-intercept, remember that this 0 right here is talking about the number of strawberries, and the y, 6.25, is talking about the number of cherries. So for this one, you can buy at most 6.25 pounds of cherries when you don't buy any strawberries. Now, this is different than what we had on the front because you could buy 6.25 pounds of cherries. Weight is something that where decimals make sense. If you're buying a number of CDs or music videos, a decimal would not make sense, which is why here, if you were to graph this, we would actually shade, whereas on the front, shading would not make sense, and we instead did these dots. All right, well, I hope you had a wonderful time taking notes on this exciting worksheet, and tomorrow we will finish with the cricket problem in class. Okay, I hope you have a good day. Bye-bye.